Lesson 9 for Day 2, Examples 3 through 5, you will find the slope of a line. Remember from the last lesson, slope is equal to rise over run. Another way to think of rise over run is the change in the y over the change in the x. Because remember, rise is an up and down movement, and that is the y value of an ordered pair. And run is a left and right movement, which is the change in the x numbers. Before we get started, I want you to just take a look here at what positive slope would look like. This line is going upwards, so it's positive. This one's going down, so it's negative. I always have a student who will say, but look, Miss Hoff, it's going up. See, watch, it's going up. Well, you're going to read the line like you read in a textbook. You're going to read from left to right. So going left to right, this one is going up, so it's positive. This one's going down, so it's negative. This one does not go up at all. It's flat. There's zero change as you move to the right, so it's zero slope. This one, you will not have to worry too much about it yet, but eventually you will encounter this situation where you have a vertical line, and that's an undefined slope. So in example 3, it says, points given in the table lie on a line. Find the slope of the line, then graph the line. Really, what we're doing here when we're finding the slope is finding the rate of change, which is what we did in a previous chapter. We're going to look for the change in the y over the change in the x. So the change in the y, I'm going to pick any 2 points here to go from this y value to this y value. It went from 12 to 9, which means it decreased by 3. So the change in y is negative 3. And then the change in x, from 1 to 3, that increased by 2. So negative 3/2 is the slope. Now, since the slope is negative, when I go to plot these points, I should end up with a line that's going downhill like this. So let's check that out. 112 means go to the right 1 and up 12. That one's actually going to go off my graph a little bit, so I'm going to just kind of guess about where 12 would be. And then 3, 9, 1, 2, 3 to the right, and 9 up. Then 5, 6 is going to be 5 to the right, and then 6 up. And then 7, 3 is 7 to the right, and 3 up. When you plot these, they should be in a straight line since it tells you that they lie on a line. And when you connect them, it should be going downhill since we know it's a negative slope. And don't forget to put arrows on both ends to show that it keeps going in both directions. You may want to pause the video and try the next 2 on your own. We're going to first calculate the change in y. From negative 1 to negative 2, that went down 1. And then from negative 4 to 0, that went up 4. So the change in y was negative 1, and the change in x was positive 4. So the slope is negative 1/4. Again, we should have a line when we go to plot these ordered pairs. It should be a line going downward. Negative 4, negative 1 is to the left 4 and down 1. 0, negative 2, you're going to stay there and go down 2. And then 4, negative 3 means I'm going to go to the right 4 and down 3. And then 8, negative 4 means I'm going to go 8 to the right and down 4. Again, they should be in a straight line and they should be going downward since it's a negative slope. And you'll want to put arrows on the ends of the line to show that it keeps going in both directions. All right, let's start with the next one. Change in y. From -2 to -1, that went up 1, so +1. And then the change in the x, -6 to -2, that went up 4. It's positive, so the slope, positive divided by positive is positive, so it's just 1/4. It's going to be a line that's going upwards. -6, -2 is to the left 6 and down 2. -2, 1 is to the left 2 and down 1. 2, 0 is to the right 2 and then stay right there on the x-axis. And then 6, 1 is to the right 6 and up 1. Oops, I just went too far there. Now we should be able to connect these with a straight line and put arrows on the ends to show that it keeps going. Now one thing you could check too is that if you were to go use your graph like we did in the last lesson, this one to go from this point to this point, you go down 3 and to the right 2. So -3/2 is your rise over run. For this one, it was down 1 and to the right 4. And over here, slope of 1/4 means rise 1, run 4. So there's several ways you can check to make sure you're on the right track. I also want to just quick point out that it doesn't matter what 2 points you use, as long as they tell you that the points in the table lie on a line, there's going to be a constant rate of change. So therefore, between any 2 points, we're going to end up with the same slope. Between here and here, change in the y from 6 to 3 is -3, and from 5 to 7 is +2, -3/2, same thing. The other thing I can show you is that you could even choose 2 points that were not next to each other in the table. For example, from 3 to 7 and from 9 to 3. So between these 2 points, the change in the y from 9 to 3 is -6, and from 3 to 7, that's +4. If you simplify this fraction, you end up with the one that we had to start with. All right, the last thing we're going to use is the slope formula. The slope, also known as m, is equal to the change in the y over the change in the x. And one way to come up with that change in y is to subtract y2 minus y1 over x2 minus x1. Basically what that means is if you have 2 ordered pairs, this is the x value from the first point, the y value from the first point, and then x value from the second point, and the y value from the second point. You can find the slope by finding the change in the y's, or y2 minus y1, this minus this, over x2 minus x1. And it really doesn't matter which one you call your first point and which one you call your second point, as long as you compare them in the same order. If you start with this one, you have to start with this one for the x's as well. All right, question number 4. Find the slope of the line that passes through each pair of points. So if I want to do this, I'm going to use this slope formula. So remember, this is x1, y1, and x2, y2. So I'm going to go like this and do y2 minus y1. In other words, I always just start at the back end. 2 minus -4 over 2 minus -1. Now if you're going to go ahead and do this math, 2 minus -4 is really 2 plus 4, which is 6. And on the bottom, 2 minus -1 is 2 plus 1, which is 3. 6/3, when you simplify that fraction by dividing both the numerator and denominator by 3, you get 2 over 1, which is just 2. The slope of the line between those 2 points is 2. All right, let's try the next one. Change in the y's, or y2 minus y1 over x2 minus x1, so -4 minus 1. Now if we go and do the math, 3 minus 2 is 1, and -4 take away 1 is -5. Now, if when you go and simplify this, you have one negative, it doesn't matter if it's in the numerator, denominator, or in the middle. As long as there's only one negative, if you were to divide these two, a positive divided by a negative is always going to be negative. So I'm going to go ahead and write it like this, -1/5. Now you may want to pause the video and try the last three on your own. Remember, change in y, 3 minus 2 over the change in the x's, which is 5 minus 2. 3 minus 2 is 1, and 5 minus 2 is 3, so 1/3. In our next example, change in the y's, -3 minus 1 over change in the x's, 0 minus -2. Now do the math. -3 take away 1 is -4, and 0 minus -2 is 2. Now this can be simplified. Once again, if you have just one negative, that means the slope is going to be negative. But then both of these can be divided by 2, so you end up with 2 over 1, or just 2. In this case, -2, since we had one negative. Now our last one, -2 minus -4. That's the change in the y's, over -3 minus -7. Now do the math. -2 take away a -4 is going to be a +2. And -3 minus a -7, that's a +4. 2/4 can be simplified. 2/4 can be simplified to being 1/2.